Okay, in our next section, we are going to cover triangles and solving them, finding sides and angles and such by using the law of sines or the law of cosines. Now, there are two things that will determine whether or not we can use the law of sines or use the law of cosines, and that's if we have an angle and its corresponding side, meaning if we have an angle and the side that are across from each other. Now, in this diagram, we do not have a side and an angle that are across from each other. For instance, we have angle C, but not side C. We have side A, but not angle A. And we have side B, but not angle B. So we're going to have to use the law of cosines, and we'll determine which one in just a minute. Now, the next thing, it says find AB. This is a capital letter A and a capital letter B. We know that the capital letters represent angles. However, if you have two capital letters next to each other, this stands for the side in between angle A and angle B. The side in between angle A and B is this side here, which is actually side C. So what we're trying to find is side C. Therefore, we're going to use this version of the law of cosines. C squared equals A squared plus B squared minus 2 AB cosine C. And we're just going to plug in. So C squared equals 17.3 squared plus 28.6 squared minus 2 times 17.3 times 28.6 times the cosine of 81.6. Now, we can plug all of these numbers in at the same time, exactly the way that you see it written. However, there's one important thing that we have to do first, so let's turn our calculator on. We have to make sure that our calculator is in degree mode. If it's not, you're going to get the wrong answer. So let's check that really quick. So I press mode. My calculator happens to already be in degree mode, and you can see because this is highlighted here. Most likely when you first turn your calculator on, it will look like this. The radian will be highlighted there. So all you do is move your cursor down to radian, move one over to degree, press enter, and voila, you have degree mode. So let's clear out of that and plug in. So 17.3 squared plus 28.6 squared minus 2 times 17.3 times 28.6 times cosine 81.6. And we're going to round to the nearest hundredth until we get to our final answer. So if we round this to the nearest hundredth, you are going to get 972.69. Next thing we're going to do is take the square root of both sides. So let's go ahead and press second. X squared, that gives us the square root function, so 972.69. And if we round that now to the nearest tenth, like we're supposed to do, you would get 31.2 feet. All right, next up, let's look at problem number 6. So once again, we're going to find the measurement, round to the nearest tenth. This time we have to find the measure of angle B. Once again, in this diagram, we do not have a side and its corresponding angle. I have side A, but not, sorry, I have angle A, but not side A. I have side B, but not angle B, and side C, but not angle C. So we'll have to use the law of cosines first. And this is going to be a two-step problem because we are not looking for a side, we're looking for an angle. So step one is going to be to use, and I'll put LOC for short, law of cosines, to find side A. Now, since we have angle A, we're going to use this version of the law of cosines. A squared equals B squared plus C squared minus 2BC cosine A. Let's go ahead and plug in. So A squared equals 11 squared plus 9 squared minus 2 times 11 times 9 times the cosine of 101. So let's plug that in. So 11 squared plus 9 squared minus 2 times 11 times 9 cosine 101. And we get 239.78. So A squared equals 239.78. And we want to take the square root now. Now, here's a little trick so I don't have to type in the number over again. I press second and I press x squared. We've done that before. And then I press second and answer, or the negative sign here. What this gives us, the ANS, is the last answer that we had got, which is 239.78. And this is a little bit more accurate because we're not rounding anything. So let's press enter. And we get 15.48, but if you round that, that is 15.5. So A, side A, is 15.5, and that would be 15.5 yards. So 15.5 yards. Now, this is all well and good, but we do not have angle B. That's what we're looking for. So we're looking for this angle here. Now, finding side A gives us a side and an angle that are across from each other. So we can now use the law of sines. And we're going to use that to find the measurement of angle B. So remember, law of sines is A over sine A equals B over sine B equals C over sine C. So let's go ahead and set that up. Now I have to use A over sine A because I have side A and I also have angle A. And then, of course, I'm looking for angle B, so I'm going to say B over sine B. I wouldn't use C because I'm not looking for angle C. So anyway, let's go ahead and plug in. Side A is 15.5 over the sine of angle A is 101. Side B is 11 over the sine of B. Now, let's go ahead and find the sine of 101. So let's type in sine 101. And if you round that, we can round that to 0.98. Remember that we are rounding to the nearest hundredth until we get to the very end. So 15.5 over 0.98 equals 11 over the sine of B. So we're going to, let me move up here, we're going to go ahead and cross multiply, and we will get 15.5 sine B equals, and let's do 11 times 0.98, and that'll give us 10.78. So let's go ahead and divide both sides by 15.5. That crosses out. I'm left with the sine of B equals, so 10.78, and I can just put divided. That's that same little trick that I used before, so I don't have to type in 10.78 all over again. 15.5, and we get 0.695, but you have to round that to 0.7. Now, I don't want the sine of B, I want angle B. In order to find angle B, I take the inverse sine. So B equals the inverse sine of 0.7. And to get inverse sine, we do second sine and then do 0.7. And we would get, if you round to the nearest tenth, 44.4 degrees. Okay, next up, let's look at problem number 7. Once again, find the measurement and round your answer to the nearest tenth. Now, we are not going to solve this problem. We are just going to set it up because I want you to realize that it's going to be the same method as a previous problem that we did. So we are not given a diagram, so we would like to add a diagram to drawing here. It doesn't really matter what your diagram looks like. Even if it's not, this is an obtuse triangle. Even if it's not, I'm just using this as a reference point. So let me add my angles, or my vertices, A, B, C. We have triangle ABC. Let's label. So the measure of angle C is 31 degrees. Side A is 15 kilometers. That has to go across from angle A, so 15 kilometers has to go down here. 28 kilometers has to go over here. And we're looking for side C across from angle C. Once again, we do not have an angle and a side that are across from each other, so we would have to use the law of cosines, so I'll call it LOC for short, in order to find side C. But this problem is exactly the same as the previous problem that we did in number 5. Let's go back to that for just a second. Remember, in problem number 5, we started off with these two sides and the angle. We did not have a side and an angle across from each other, so we had to use the law of cosines. So problem number 7 is going to be solved exactly like problem number 5. Okay, so we are going to jump to problem number 9, and once again we are going to set this up, not solve the whole thing, but this says find the measure of angle B, and we have triangle ABC, but this time we have a side and an angle that are across from each other, and we have to find this angle. So we can use, and I'll call it LOS for short, the law of sines. So we're just going to go ahead and set it up once again. Now, we know that the law of sines is A over sine A equals B over sine B equals C over sine C. But I can't use the A part because I don't have angle A and I don't have side A. So we have to say B over sine B equals C over sine C. And if we plug in 10, which is side B, over the sine of B, that's the angle that we're looking for, equals 17 over the sine of 108. And we are not going to, I'm not going to go through the whole thing, but you should know how to solve this one because we've done a previous example. All right, let's go to the next problem. And problem number 10 this time. So it says find, this is read as side BC. Side BC is the side that's in between angle B and angle C, and that happens to be across from angle A, so it's actually side A that we are looking for. Now, at first glance, you might say to yourself, hey, I don't have a side and an angle that are across from each other, but this time we have two angles. So your first step in this problem would be to find the third angle. If you have two angles, you basically have the third one. The third angle is angle B. In order to find angle B, we are going to do 180 minus 39 minus 96. And 180 minus 39 minus 96 is 45 degrees. So I can write that in there. So now I have angle B and I have side B. And we're asked to find side A. So in order to do that, we're going to use the law of sines. So step 2 would be to use, and we'll say LOS for short, to find side A. And let's just set it up. So A over sine A equals B over sine B. And I'm just going to plug in. So A over the sine of 39 degrees equals 27 over the sine of 45. And that is not too difficult to solve. So this concludes part 2 of the midterm review. There are 2 more problems, or a few more problems, but they're all solved exactly the same way that we've set up or either solved all of our problems thus far in this video.